Welcome back to part 2. In part 1, we set up this triple integral by determining the order of integration and the corresponding limits of integration. In this video, in part 2, we'll evaluate the triple integral. So notice how we first integrate with respect to z, treating y as a constant. So the antiderivative is going to be y times z. And now we need to find big F of b minus big F of a by performing substitution for z. So we'd have y times the quantity. First z is equal to 11 minus 4y. Then we have minus z is equal to x squared. So now we have a double integral, where now the integrated function is going to be 11y minus 4y squared, and then minus x squared y. And now we integrate with respect to y, treating x as a constant. So we'd have 11 times y squared divided by 2, or 11 halves y squared, and then minus 4 times y to the third divided by 3. That's going to be minus 4 thirds y to the third. And then we have minus x squared times y squared divided by 2, or minus 1 half x squared y squared. This is where things start to get very messy. We now need to find big F of b minus big F of a by performing substitution for y. So first, y is equal to 11 fourths minus x squared divided by 4. So we'd have 11 halves times the quantity 11 fourths minus x squared divided by 4 squared minus 4 thirds times, again, the quantity 11 fourths minus x squared divided by 4 to the third minus 1 half x squared times the quantity 11 fourths minus x to the second divided by 4 squared. And then when y is equal to 0, luckily every term does have a factor of y, so each term is going to be 0. Now to simplify here, I'm not going to show every step. Hopefully you're able to use an algebra system to perform some of this algebra. If we square this binomial, cube this binomial, and square this binomial, then distribute, we'd end up with the following. 11 x to the fourth divided by 32 minus 121 x to the second divided by 16 plus 1,331 divided by 32. So these three terms are from squaring this binomial, then distributing 11 halves. Then we'd have plus x to the sixth divided by 48 minus 11x to the fourth divided by 16 plus 121x squared divided by 16 minus 1,331 divided by 48. These four terms come from cubing this binomial and then distributing negative 4 thirds. And finally we have minus x to the sixth divided by 32 plus 11x to the fourth divided by 16 minus 121x squared divided by 32. And these three terms come from squaring this binomial and distributing negative 1 half x squared. Now we want to combine the like terms, which would give us negative x to the sixth divided by 96 plus 11x to the fourth divided by 32 minus 121x squared divided by 32 plus 1,331 divided by 96. And now we need to integrate with respect to x. So here we'd have negative x to the seventh divided by 7 times 96 plus 11x to the fifth divided by 5 times 32 minus 121x to the third divided by 3 times 32 plus 1331x divided by 96. And now we need to find big F of b minus big F of a by performing substitution for x. Of course, we could simplify these denominators. Let's go ahead and do that first. Again, I'm not going to show all these steps here, but when we substitute the square root of 11 for x, we end up getting 1,331 times the square root of 11, all divided by 210, and then minus, when x is equal to negative square root of 11, we end up getting negative 1,331 times the square root of 11 divided by 210, which gives us 2,662 square root of 11 all over 210, which does have a common factor of 2. This simplifies perfectly to 1,331 square root of 11 all divided by 105, which as a decimal is approximately 42.0422. So this would be the exact and approximate value of the triple integral. I hope you found this helpful.